This video is a presentation of the development and final creation of the Convolin, a novel digital string instrument. It all began with a paper from the Conference on New Interfaces for Musical Expression, or NIME, by a member of the MIT Media Laboratory. The paper explored the use of convolution in percussive physical controllers. For the purpose of this presentation, convolution is defined as the resultant signal of two sounds combined into one. My first convolution experiment consisted of miking a snare drum and combining it with the tails of other instruments, such as a cymbal. Combining the snare hit with a cymbal results in a typical snare hit followed by a sparkling metallic reverb tail. After experimenting with the percussion instruments, I was curious as to what would happen if I did the same with a guitar. If one plucks a guitar string and combines that signal with that of a cymbal, the result is not so different. However, bowing the strings created a much different sound. The result was the sound of a string instrument, completely altered in timbre and overall spatial quality. The uniqueness of the bowed string convolution was something decidedly worth exploring further. However, my previous attempts at playing string instruments were thwarted by tiny hands and poor fine motor skills. These shortfalls led to the idea of creating a digital hybrid of this, a classical cello, and this, a Guitar Hero controller. If you are unfamiliar with the popular game Guitar Hero, the sound is controlled by holding down one of the buttons and strumming the plastic lever to produce a preset note or chord. Utilizing Google's SketchUp, a conceptual idea for the physical instrument was created. It progressed from a simple concave bowed frame into a single string instrument, and then into the final instrument with two strings, tuning pegs, and a digital fingerboard. This design was then fully developed into mechanical drawings, which would be used for the actual fabrication of the Convolin. The digital fingerboard contains 17 pitch buttons, oriented in the manner of a left-handed piano. It also contains 3 preset buttons for changing the convolution, as well as a reset button. The first functional prototype was built out of a wire frame and fiberglass. The final instrument was machined out of stainless steel by the Queen's University Engineering Department. The strings are tuned to A2 and A3. The program used for the Convolin was developed in Max MSP. The first important section is the input, which is processed by the pitch object. The pitch object has the ability to assess the incoming signal in various terms of note, frequency, and amplitude. The frequency information is then sent to multiple copies of the shifter object. Shifter manipulates the frequency of the signal. In this case, each button triggers the shifter object to pitch shift the input based on the respective semitones. The lowest used is -9 semitones. 0 is the actual string pitch. Negative lowers the pitch, and here we go up by semitones all the way to 7 semitones above, or E, making the range of the instrument essentially that of a cello, minus 1 octave in the higher range. Here I am demonstrating the pitch shifting of the raw signal. As you can hear, The instrument is fully playable as is, though the sound itself has very little depth or character. This is where the convolution comes in. Here we have the convolution section of the patch, based on the tconvolv external. This button chooses the file, then we load the file, select the rate, and then the patch is essentially compiled with a click here. And we can monitor and adjust both the input and output. Let's go with a delay tom. Here's the patch, locked and ready to go. Let's hear that delay tom. As you can hear, the entire timbre has changed. Here is an echoed crash cymbal. This is a snare drum with reverb on it. This one is convolved with a fun sample called robo-chorus. The convolin can also be used to play chords. Though the bow is unforgiving, and an inexperienced drum player like myself may find it difficult to keep a steady tone. The convolin can be used with any random sample, such as bagpipes. The convolin system is a unique, versatile instrument with nearly limitless sonic possibilities and maximum user control.